I'm Eric Siegel, CEO and co-founder of Gooder AI, and in this video I'll cover what is a profit curve and why do all predictive AI projects need a profit curve. We give data to machine learning, it generates models that predict, and those predictions improve all the main large-scale operations that we conduct as organizations, which is why we call these use cases of machine learning predictive AI or predictive analytics. And we can see the function served by the predictive model learned from data as a way to prioritize or triage to decide which individuals get a certain treatment, such as contacting for marketing. So for example, I used to have my students stand up and get in the order of the size of their TV. So they'd all hold a piece of paper up with the number of inches of the largest TV in their house. 0 means they don't have a TV. Maybe they watch on their laptop, if at all. And then I ask, who has a subscription to Netflix? Now, as you see, you tend to have a lot of yeses towards the beginning and very few yeses, more nos towards the end of the list. That's exactly the same kind of pattern that we see across predictive AI projects in general, across sectors, across types of operations you're improving. We don't have a magic crystal ball, but we're going to get these kinds of trends. We have that ability to put them into a meaningful order and then draw a line somewhere and say, hey, I'm going to decide to only contact with marketing included in a marketing campaign, the top third. And as you can see, we're going to get a lot more bang for our marketing buck by only targeting the marketing to that top third, most likely to be a subscriber to Netflix. If we're selling a product that has somehow some affinity to Netflix in this case, than we would if we were to spend marketing for the entire list as a whole. So the same concept is represented by a profit curve, following the curve at the top. As you go from left to right, it's the same order. Most likely to buy if contacted, down to least likely. And if we were to contact the customers with marketing in that order from left to right, towards the left, our profit would be increasing most steeply because those upper echelons of the list are most likely to buy if contacted. That's where we're getting the most bang for our marketing buck. Then we have kind of diminishing returns as we run out of those upper echelons, and it starts to even out, peter out. And then in fact, it starts to go down and we're only losing money and negatively adding to our cumulative profit as we continue to go down the list further if we were to do so, because we're just not getting enough marketing bang. We're not getting enough response for the marketing investment. So your first thought might be, well, let's only market to the top 24%. So that dotted line is called the decision boundary. You may be familiar with the idea of a decision threshold. The decision threshold directly controls the boundary. They have a direct correspondence. But I use the word boundary because we're not talking here about the model probability threshold. We're talking about the proportion of cases that are going to be treated, in this case, contacted for marketing. But it's the same thing that would apply for deciding how many transactions are going to be audited or blocked as potentially fraudulent, how many machines are going to be investigated as inspected as potentially breaking down, et cetera. But it's not a foregone conclusion that you're going to draw the line there. So again, we've ordered from most likely to buy if contacted down to least likely. According to this forecast of the potential profit, if we were to act on the model, if we were to deploy it, in the case for marketing, if we were to target the marketing only to those top 24% with the highest scores, according to the model, most likely to buy if contacted, then our profit would peak. But we have a range of options. We can put that decision boundary anywhere we want, and there are other pragmatic factors. So for example, if it's a new product and the business stakeholder says, look, what I care more about these days in the immediate term is to get the word out. Maybe we should draw the line here at 73% and thereby break even. Basically for free, contact 73% of the list. Arguably a lot better choice than spending $550,000 to contact 100% of the list. So this profit curve, both dimensions are something very rarely seen when predictive AI projects are conducted. Profit curves are actually rare, and our mission is to change that. The x-coordinate from left to right, that's where do you draw that decision boundary? and we have this spectrum of options that may depend on marketing budget, may depend on other competing KPIs, but we have that wide range of options. And for each one of them, we can estimate the potential business value in terms of business KPIs, business metrics like profit or savings, monetary performance, that is to say, or any and all other KPIs, whatever the metrics are that matter to the business, right? Typically, predictive AI predictive models are evaluated in terms of technical metrics like AUC, F-score, precision recall. Even accuracy is only a technical metric, doesn't necessarily tell you anything about the business value. So the Y coordinate from top to bottom is also rarely seen. So just to make sure this it's entirely clear, I made this little widget, and so I'm just going to illustrate the same concept. From left to right, most likely to have, and this concept applies to any predictive AI project. From left to right, we've ordered, prioritized, triaged according to the model's score. So from left to right, most likely to have the outcome or behavior that we're predicting for this project. That's going to help us drive some kind of treatment decision, right? Whether to contact, audit, inspect, etc. And everything to the left of the decision boundary is given that treatment. Now, you might be choosing between an active and a passive treatment, like whether to contact or not. So everything to the right would be not contacted or not treated. Or sometimes you're choosing between two active treatments or what have you. But in any case, as we go to the left, we're targeting more narrowly. And if we go to the right, we're targeting more broadly, but not as precisely. So we're going to tend to try to strike some balance between not going too far to the left and not too far to the right. Don't contact too many, don't contact too few. Don't audit too many, don't audit too few, etc. So in general, from left to right, let's talk about something that's risky, like some transaction that could be fraudulent. We've ordered from highest risk down to lowest risk, and choosing that cutoff point, that decision boundary, often has a greater potential impact on the project, its value from a business standpoint, than improvements technically to the model itself, whether that involves a more sophisticated or better modeling approach for this problem or better data and what have you. Those things can help, tend to have diminishing returns. This is a very undernourished area in predictive AI projects of like, okay, well, now that we have a model or some competing models, let's look at how their potential value varies according to that one dimension, that continuum of options of where we draw that decision boundary. And if we were to decide to treat anyone in that range, right, the cost, that would be a business metric. If we were, let's say, doing fraud detection, the aggregate cost would be, well, how much do we lose from fraud? But also, how much do we lose from falsely blocking transactions that are legitimate? That has a cost associated with it as well. And in general, the cost lower is better, so that midpoint is kind of the Goldilocks zone. Don't block too many transactions, don't block too few. Now, cost is the negative view of savings, right? Or savings is kind of profit because a penny saved is a penny earned. But if we take the cost and kind of turn it upside down, it's sort of the inverse. That's why we have Goldilocks skipping rope. But either way, it's saying, look, we want to head somehow probably to the midpoint, at least according to this one KPI. There may be other competing considerations as well. And in fact, that's what we see. So what Gooder AI does is it draws profit curves. It does a bunch more, and I'll talk about that in a moment. But what we see is the same basic pattern for predictive AI projects in general. Whether you're deciding where to draw the decision boundary to maximize profit for targeting marketing, for soliciting donations, for targeting nonprofit fundraising, for deciding where to draw the line, how many transactions to block is potentially fraudulent for fraud detection, how many applicants for credit to approve, how many shopping carts for e-commerce to offer a spontaneous discount to. If you offer a discount to someone who's going to complete the transaction anyway, that's not a good idea because then you've only decreased your revenue. But if you don't offer a discount to someone who's a high risk of abandoning their shopping cart, those over to the left in this case, then you're also missing an opportunity because they may just leave without completing the transaction. So again, there's this Goldilocks zone. You see here that comparing two models and only one of them was actually successful, but it had a nice Goldilocks zone at 8%. Offer that discount to the top 80% most likely to abandon. Again, in general, it goes up and then it goes down. Misinformation detection. So this is a very just as horizontal as machine learning in general. We've had users of Gooder AI at companies applying predictive AI across a wide range of sectors, a wide range of use cases of machine learning, of predictive AI, microloan risk, checking fraud, churn modeling to target customer retention, healthcare patient no-shows, etc. So that's your introduction to profit curves. In the next video, we're going to talk about why profit or other business metrics are so critical to forecast or estimate in a predictive AI project. We call that ML valuation, not just ML evaluation, but valuation. Why is it so critical? And then in another video, we'll cover why is it so rare? If it's so important, why is it so rarely done? And in fact, why does it require a very specialized, particular new kind of software product?